Hello, welcome back to Cracking the Cryptic and puzzle by Chris Napolitano. I think it may be a debut for Chris, but it's a very interesting idea, and although there are quite a few given digits in this puzzle, I'm left a bit confused as to how it can solve. We will look at this in a moment. Really interesting. Anyway, don't forget that on Patreon, we have the rather wonderful Sudoku hunt called Hollywood Lunchbox, a number of sandwich Sudoku puzzles, and a bit of trivia for film and TV buffs. That's just part of the jolly good fun going on Patreon all the time. And of course, there's all our apps, which include classic Sudoku and our latest Approachable Sudoku, amongst all sorts of other variants as well. So do check those out. They're great for practicing your skills. We've also, of course, got Sven's SUDOKU PAD, which is great software. Do support Sven, marvellous guy. And our merchandise, if you want some of that. We're getting into the season when you might need a hoodie soon. Anyway, let's have a look at Mad for Diagonals by Chris Napolitano, which has got a surprising rule set. I'm going to go through it now. Normal Sudoku rules apply. That's 1 to 9 going in every row, every column, and every 3x3 box. Cells with grey squares in them contain even digits. We've seen that before. There are 8 grey squares in this puzzle. Here comes the rule that matters. In this grid, the digit 4 is the only even digit that is allowed to see itself diagonally. Now, what does seeing itself diagonally mean? It means that if this digit was a 4, it sees that 4 diagonally because it's on the same diagonal, of the puzzle. And that means that 2, 6, and 8 are not allowed to see themselves diagonally. Now, we've had this idea in Queen Sudoku, which is part of Chess Sudoku in our apps, where it turns out to be, well, the rule is that 9s can't see themselves diagonally. So you have to find an arrangement of 9s in the grid where none of them share a diagonal. Now, we have to do that for 2s, 6s, and 8s in this puzzle. But I'm just a bit surprised this is enough rules. Anyway, let's see how we go. Give it a try on the first link under the video. I'm going to start now. Let's get cracking. And first thing I notice is there's an awful lot of 7s given in the puzzle. So by Sudoku, there's going to be a 7 in one of those cells and a 7 in one of those cells. Also, I don't know, apart from 7s, there aren't a lot of given digits of any one particular breed. So I don't know, maybe there isn't. I thought maybe there would be some Sudoku we could do to get started, but it hasn't really worked out that way. So I am going to look at the even cells, the squares provided. This one, for instance, cannot be 2 because it's on a diagonal with that 2. So, well, let's start here. This can't be 2 or 4 because of the column. So that is 6 or 8. I might as well mark the candidates here. This one could be 4, 6, or 8, as far as I can see. This one, well, it's on a diagonal with a 4. I mean, we're only given 2 of these instances of digit, and this 6 doesn't hit anything diagonally at the moment, I don't think. No, it doesn't hit any squares anyway. And the 2 only hits 1. So they're not very helpful. I mean, I could write 2, 6, or 8 into those cells and that one actually. How on earth? I mean, this could be a very short video if I don't understand how we can solve this puzzle. I mean, it goes beyond that. I'm wondering if this puzzle can possibly solve at all. I don't really get how it can. There's no rule about odd digits not being able to see each other diagonally. It just doesn't feel like there's enough information here in any way. There's obviously only 15 given digits and these squares and the rule. Oh, okay. It might be, and this is all I've got, so it had better be. It might be a colouring puzzle for the even digits. Right, this is a bit tricky. 4s are allowed to see each other. I'm going to colour them yellow. I'm not going to colour the 2 and 6 yet. I'm going to colour these digits because look, well, I don't know that there is enough going on here, but let's say that that was green and that this was purple. These must be different digits, obviously, because they're in the same row. Look, they both see that right. Yes, 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 yes. Let's make this blue. So that these three are a triangle. And it's a slightly scalene triangle, but it is a triangle, and it's a triangle in which all the points see each other. These two can't be 4s, so they're part of this group of digits which aren't allowed to see each other diagonally, so they must be different. This is also, given that it's an even digit, we've been told that by the square, that is also one of these, but these three all see each other. Those two on the diagonal, those two on the horizontal, and those two in the box. This is quite funky. So now I'm going to trace down this diagonal, and look, they hit that. So this isn't allowed to be purple or blue, and therefore this is green. And therefore green, which is down here 6 or 8, must up here be 6 or 8. And I'm beginning to now dimly perceive how we could actually make some progress. Now the trouble with this, oh look, this sees green as well on the diagonal. So this now sees green, blue and purple, and it must be yellow and be 4. Oh, this is so clever. Right, there's a 4 in one of those cells and a 4 in one of these two. This one, look at that, this sees yellow, green and purple in horizontal and vertical, so that's blue. And that sees this cell, which also sees green. Well, that's tricky, because this could be yellow or purple, and I don't see how I know which. But maybe I can just colour something. First of all, bit of Sudoku, there's a 4 in one of those cells. That's it. I haven't got any more exciting Sudoku to worry you with. Can I colour blue? Blue can't be there for the diagonal. So blue's in one of those two cells. So I'm going to sort of halve the cells because I don't know which of those two is blue. But then I do know where blue is in column 1. It's there. It's not the 1. So then blue is in one of these three, but one of them will be on this diagonal. Yes, that central cell will be on that diagonal. So one of those two is blue. Now, this blue sees all of those cells, and this one sees that one and that one. So the blue in the central box, oh look, and this cell sees that one. So there's only one place for blue. It's there in the central box. That sorts out where blue is in box 4. Now blue can't be there because of that on the diagonal. Oh, this is lovely. Blue's in one of those two. And down here in box 8, it's got to be there. Again, looking at the diagonals. That looks up to this cell on the diagonal. So blue's in one of those two. And that one is on the same diagonal as that, so it's there, and we've suddenly discovered that blue is a 2, which is very, very pretty, because now we can highlight all the blues and put in all the 2s. My goodness, this is very, very clever. Now, I want to move on to 4s, but 4s don't have the restriction, and it feels like the restriction is the big deal. Can I possibly do anything with green and purple? Yes, look, that green cuts off that cell out of box 3. So all those can't be green, and that one that pair must include green. Then this pair includes green in box 6, but that cell sees that one, so we place it. This is marvellous. I'm very, very impressed by the idea here. Oh, and look in this box. Oh, no, I was going to say green must be here, but actually green could be 6. I have to bear that in mind. It's very tempting to see all the given digits in the puzzle and go, well, you can't put green or purple there, but that is a dangerous and superficial view, because with this one, it could be green or purple. So, okay, this can't be green. Yeah, that's no use. This green sees all of those cells, and this one sees that. So green in the central box is in one of those two. And now look, they have relationships, these two. They see both of those cells. And green is 6 or 8, so it can't go in any of the givens here. And that green sees that cell. So green here is in one of these two. And is there some sort of relationship here about green? Well, that's an X-wing. It's going to use up all the greens in column, all the green positions in columns 3 and 4. So now none of these can be green, including this cell. And given that we've got green there, green can't be here. Green can't be here. So this 6 is green. And we now know that green is the number 6. That's so interesting. Oh, and that 6 sees this cell. So that is ruled out. These two are ruled in, and that's ruled out. And these two are 6s. And we might well be able to complete green. Well, I can write an 8 in purple, obviously, now. But can we complete green? That was green, wasn't it? We need a green in one of those two. Surely the diagonal knocks one of them out. No, I don't think it does. Okay, up here, those are ruled out by vertical. That 6 is hitting that, and this 6 is hitting that cell. So 6 is here, and that is going to give us a 6 in box 7, and the 6 in box 2, and all the 6s are done. Now, 8s. 8s have the diagonal rule too. That is a straightforward 8. We didn't even need the diagonal rule for that one. But what about other 8s? By the way, this is just so clever. I love that this works as a puzzle, and I now believe it does. 1, 4, 9. I'm still a little bit surprised. Not only because I can't make 8s reach into any boxes. I mean, one of these 3 is an 8, but I don't know which. One of these 3 is an 8, but I don't really want to pencil mark all of them. And this box. So it's not just that. See, 8's in one of those cells. That doesn't seem very helpful. It's not just that 8's might be difficult. I'm not really sure how easy it's going to be to get the odd digits done, because all we're learning in this process is a few cells where they can't go. Presumably that's going to be enough. Oh, in box 9, those two are ruled out by one of them, and that one by the third. So there are 3 positions for 8 in box 9. This one, sorry, I was trying to say was on the same diagonal as that cell. Just checking. Yeah, okay. So those 3 all see this cell, which can't be an 8. And these 3 all see that cell. So I think 8s in box 8 are ruled into one of these positions. Now, how am I going to make that help? That's the only cell I can eliminate as an 8 in box 2 out of the white cells. This is feeling a bit strange. It's almost like there just isn't enough information. I'm sure I have to focus on 8s next, i.e. now. Or maybe I do more with 4s, but I mean 4s don't have the Queen's move constraint. Yeah, no, I want to keep focusing on 8s because I've got used to this diagonal method of looking, and before I give that up, I'd love to... Oh, look at that. If that was an 8, that's really interesting. This is very unexpected. If that was an 8, the 8 in box 9 is there, and then there's nowhere in box 5 to put an 8, because that one, the box 9 one is on the same diagonal as those two, and the box 8 one is on the same vertical as that. That's weird. So this can't be an 8. So one of these two is. That means that's not an 8. So this is now a 4-8 pair. And that's a 9 by, it's the last digit left. 1 is in one of those cells. 1 doesn't have the rule applying, so I can't rule it out of here. So, I don't know, was that enough? If either of those is an 8, they see that cell. Or maybe I start with this cell, which sees both of those. Ah, and both of those. Yes, that's beautiful. This can't be an 8, because all of these would be prevented from being an 8. So the 8s in box 5 and 9 would be, if that was an 8, would be there and there and there, but they're on the same diagonal. So that can't be an 8. Sorry, can't be an 8. So this is the 8 in box 8, which rules out the center from being an 8. Sorry, I'm all over the place. And in fact, the center now has to be a 4, which is colored yellow. That's the 4 now in box 2. 4 is in one of those two cells. 4 doesn't have the rule. Maybe I can't go any further. That's annoying. That one can't be a 6. Now, okay, where's 8 in box 6? Only that one has been ruled out by the two. Oh, this is purple. Hang on, that's going to get a bunch of cells in box 6 removed as possibilities. So now 8 is in one of those 3. But 8 is definitely in one of those 2 now in box 5. So we can rule out those. Stick 8 in there, and that might get the job done, will it? Yes, look, that sees both of those in box 9. This is brilliant. Chris, you've absolutely nailed this idea. That is going to finish 8 and 4 in box 7. Then we're left with a little X-wing on 4s in this 2x2. Luckily, they don't have the diagonal rule, otherwise that would be impossible. That's an 8 in box 3. There must be only one 8 to put in the grid. There it is, and all the 8s. So now we've done all the diagonal digits. The rest of this puzzle is straightforward Sudoku, except for this is an even digit, which now must be 4. So now we've done all the even digits in the puzzle. And the rest is straightforward Sudoku. Oh, I didn't fill in this 8, did I? Sorry. The rest is straightforward Sudoku on odd digits. That's the 4. Well, it is if I would actually just complete what I'm talking about. Sorry, this is a problem with talking and trying to actually do deductions in my head at the same time. So, now we're left with my skepticism about filling in the rest of this. One of those is a 1. So one of those is a 1. One of those is a 1. One of those is a 3 because 3 is sitting there looking at those cells. So this is 5 or 9. Still doesn't really feel to me as though there's enough information for this, which is a strange feeling. That's 3 or 9. This is 3 or 5, since it can't be 1 or 7. Oh, maybe I should finish off 7s if I can. I can't. 5 is in one of those two cells. Are we going to have to do some other sort of Y-wing thing like we were doing with the diagonal rule? How's that going to work? It just feels difficult, this. Okay, if that was a 5, that would be a 5. One of those would be 5. One of those two, that's no use. If that was a 5, one of these two would be 5, and one of those two, and one of these two. That couldn't be 5. This feels a little bit closer to doing something, but not very. No, maybe it's another digit. If that was a 9, that would be 9. Then 9 would be in one of these cells and one of these two and there. This is tricky. We're going to have to find the right question here. And the questions might be better bit by bit. If we get the right question somewhere, we might manage to eliminate one cell from being a digit and then use that to do the same sort of questioning again. I don't know though. I've got so used to being allowed to use the diagonal rule that it's very hard to give that up at this point. That should be a 3. If 5 was down here in this column, 5 can only be in one of those 3 cells in column 5. If it was down here, that would be a 9. This would be a 5-7 pair. That would be a 3. What does that do? Does that do something to the puzzle? The answer's no, it doesn't really. I'm scratching around now. There's got to be some way to go. That 1-9 pair is putting 9 definitely in one of those cells. Now, what else can we do with 9? If that was a 9, that would be 9 and that would be 9. I'm desperate to find some way in which this just falls apart. That would be 9 in column 6 at that. No, in row 8 at that point. That would be 9. One of these would be 9. We know one of those is 9, so that would be 9. One of these two would be 9. This can't be 9. Right, I'm onto something, and I just have to work out what it was I was onto. How did I start this? Did I say if that was 9? No, I can't remember how I started it. This can't be 9. This is 3 or 5. So 9 in this column is in one of those 2 cells. Now what's that proving? It's proving something. This is a naked single. There. It's that simple, sorry. 9, 2, 4, 8, 6, 1, 7, 5. This is a naked 3. That's how we get going. Then this is a 1, 5 pair in the row, but in the column, this is a 1, 9 pair. This must do something. Naked 3. It's got to. No, look, I'll tell you what, that can't be a 5, because that would be 5 in box 3, and there'd be nowhere for 5 in box 6. That one sees that cell. So that is actually a 1, not quite naked, slightly complicated 1. But I think we might have enough information now. That's a 3-7 pair, so 7 goes there. Then we've got a 5-9 pair still to resolve. One of these is a 3, maybe, I don't know, the 1 there, yeah, that places 1 in the top row. That is going to leave a little X-wing on 1, so it's going to place 1 in row 6 there. That fixes 9 and 1 over here. Now, I'm left with those 1s, but this 9 thing is saying 9's in one of those 2 cells, and we know 9 is in one of those 3. So the 9 in column 7 is up at the top somewhere. Maybe I can't use that after all. That's 1, 3, or 9. One of these is a 3. This central box feels under pressure, maybe even more than before. This is a 3, 5 pair. This one is 3 or 9 in its row. 3, 5, 9, still to resolve everywhere. So we're not done yet. Chris still has something up his sleeve. 7, 8, 2, 6. One of these is a 3. Well, let's do this final box again. So, or box 8 and 9. If whatever that is here, let's make that orange. And it's in one of those 2 cells. Aha! So in box, whatever this is 5 or 9. In box 6, it now can't be there or there, and it must be there. So to be in orange in all of these cases, it's a 5, and in fact it's there in box 5. That's orange. This isn't. And that is going to finish our puzzle. That's now 5 in box 3. We've already got a couple of 5s in the grid. And indeed, there's only 1 left to put in. There it is. Okay, so that's all the 5s done. This is now a 3 by Sudoku. That's a 9 in the column. That's a 1. Now we are just finishing off rows, columns, and boxes as we find them, which is a relief. That's 3 in the corner. That's 3 in the spotlight. It's losing its religion. 3 there, 9 there, 3, 7 and 9, and 7 and 3. What a rather excellent puzzle. That's really interesting. And it has surprised me in several ways. What a brilliant thing. Mad for diagonals. Well, I am now, Chris. That's very clever. Most entertaining. A colouring puzzle when I least expected it. And marvellous. Thank you for watching, as always, on the channel. I've enjoyed that. Hope to see you again soon. Bye for now.